Today, I'd like to give you a presentation about my project in computer vision, and my topic is cross-modal retrieval by Trigonal partial least squares. I will talk about this research in these 6 aspects. First, let's move to the motivation. As the high development of the internet and machine learning, the big data era is coming, and the multimedia information is increasing dramatically. And you will ask me, what is cross-modal retrieval? Well, the cross-modal retrieval is matching one model feature to the other model feature in content-based area. For example, in the areas of image and text retrieval, I will give you the text that is best describe the image query based on content, and I also return you the most related image according to the text queries. The most difficult challenge in cross-modal retrieval is the different features between two modalities, and then they can be matched directly with each other. After a simple introduction about the cross-modal retrieval, I'd like to say some methods that have been done in cross-modal retrieval. Well, the subspace learning method have been widely used in cross-modal retrieval, which they can project two different model features into a common space. Well, the CCA is one of the subspace learning methods, and in our method, I'd like to use the partial least squares, which is also the subspace learning method. And the partial least squares is aiming at learning two latent spaces by maximizing the correlation between two latent spaces. Well, have research about for this traditional method is that they don't use the neighbor information, which can decrease the semantic gap theoretically. So, in our method, I'd like to propose a supervised algorithm called Trigonal partial least squares, where the generated common feature space can be learned for two modalities to be matched directly. And the contribution of our model are two. Well, the first one is the TPLS regard the label information as the third modality, and then we achieved to maximize the correlation between the two multimedia modalities and the label modalities based on KPLS, which is the kernel partial least square. And the second one is the label space. Second one is that we found that the label space will not be same again in the two KPLS processes. So we add the constraint to minimize the distance of the target space, so as to reach the target space close to each other as possible as they can. And then I will talk about our model. Before I talk about the TPLS model, I'd like to give some simple introduction about the partial least squares. Well, as you can see, this is the original object function about the partial least squares. In this equation, the x and the y are the input variables and the output variables respectively, and the v and the u are the latent vocabularies, and the p and q are the metrics of loading. And as you can see, the delta x and the delta y are the residual matrix, and here the b is the coefficient matrix. By solving the object function, we can get the regression coefficient matrix b like this, and you can see the y can be obtained through we can solve the method of after an introduction of the object function. We can solve this one by Nippel algorithm, which you can find more details in my paper. And after solving the object function, we can get regression coefficient matrix b, which you can see as this, and then the b can be got to the regression between x and b. That is just the original one, and that is just the original object function about the PLS. And here the equation 5 is also one form of the object function like this. And here this signal means the inner product of vectors. And after the introduction of the basic partial least squares, I'd like to talk about our model, trigonal partial least squares algorithm. And here is the global diagram about our model, and I will talk about this in details. And here is our talking a simple introduction about the PRS. I'd like to talk about our model, TPRS. And here is the diagram showing the global of our model. As you can see, the circle in here is just the original space, like the X means the image features, and V means the text features, and L means the label features. And you can see the square means the latent variables, and the dotted squares means the latent space here, and this green one. And after just a global knowledge of our model, I'd like to talk about our model in more details. And here, as you can see, the equation 6 is our object functions. We'd like to minimize the sum of the G process, D process, and P process. And here, the G process and D process and P process are denoting the latent variables correlation constraint, distance of iteration output constraint, and the transformation constraint, respectively. And firstly, let me talk about the latent variables correlation constraint. As you can see from this global graph, we'd like to minimize the correlation between the multimedia modalities and it is label modalities. And then we have this one, G1. And after calculate the features, well, in this section, I'd like to talk about object kernel and the definition details, which you can also regard the definition details as the optimization of our model. As what I have just said, that our model is based on kernel partial least squares, and then we just choose to use the RBF kernel to calculate the kernel features for the images and text as the equation 18 shown at here. Then I'd like to say something about the definition of the KPRS. And here the XIJE means and here is the definition of the KPRS, which is different from the PRS, and you should pay attention to here. And this is the place that I show why now label space will be different in the iterative process. And here is our optimization. We choose to optimize our object function just through the gradient descent. And here is the result. The more details you can find in my paper. And here I just show the result. And then after I talk about my model, I'd like to say something about my experience. We have just done two experiments on two popular data space. The one is the Wikipedia, and the other one is the Flickr. The more details about Wikipedia and Flickr you can find in my papers. And here, I'd like to tell you that we compare our approach with PRS, kernel PRS, the semantic correlation matching, which is the model proposed in ACM Multimedia 2010, and the correlated semantic representation, which proposed in BMVC 2014, and the generalized multi-view imaginary feature analysis, and the generalized multi-view LDA, which is proposed in CVPR 2012. Here I have just give you a description about our setting of experiment, and then we are moved to the result. Well, here is the MAP, which is the mean average prism of our model in Wiki dataspace. No matter it is the image to text retrieval or text to image retrieval, our model have just to achieve the best result in this database. And here is the PR curve, which is the present recall curves. And you can see in the image to text query tasks, our result is not very good in the whole recall, but in the text query task, we have just achieved the state-of-art result over other methods. As for the Flickr database, our MAP value is also the state-of-art one. Here is the PR curve showing for Flickr database. As you can see, different from the wiki database, in the image query task, we also get the best result in this database. And as for the text query tasks, we also get the state-of-art result. And next, I'd like to give a conclusion about our paper. Well, in this paper, we just propose a novel method to solve cross-modal retrieval problem and apply it to the image text cross-modal retrieval. And secondly, in our approach, we regard the label information as the third model, so as to construct 3 KPIs between any two modalities. And furthermore, we add a distance constraint of target space so as to achieve learning the consistent feature in cross-modal retrieval.